Alright, so this video is dedicated to inseparable differential equations, and specifically those that involve an integrating factor. And we will learn more about the integrating factor later. But first, just to make sure you're on the right deal here, I want to make sure you understand what a separable differential equation would be. And if you're watching this video, you've already done separable differential equations. Those are something. Now this one's separable. Separable differential equation is something that looks like this: dy over dx equals x over y. We can just use the butterfly method, go in this direction, and easily get each variable by itself. You see how the y's are just on this side, the x's are just on this side. We can take those integrals, and then we can easily come up with a solution. And don't forget that plus c. Alright, so then you can multiply by 2 to simplify that out a little bit. But we're good with that. So that's separable because we could easily get y and x on the same side. But just because you can't get y on one side and x on another side like this, like we did so easily here, doesn't mean you can't solve it. Alright, so let's move on to what this is really about, and that is inseparable differential equations, and specifically, like I said, those using an integrating factor. You won't know what an integrating factor is for another couple minutes, but it'll all make sense once you do. Okay, so let's first we need to figure out. I need to show you what the standard form for integrating factor is, meaning the form that we need to make sure that we get whatever we have into. Okay, so if you see an equation, you figure out it's not separable easily, then we want to come here and maybe use this integrating factor. And there are a couple other types too of differential equations and other methods you can use, but this one is one of the more common ones, and probably the one you've learned first. Okay, so this is the standard form, what we're going to call standard form for integrating factor, and all that means is that's what we have to get. Whatever problem we have to get it into this. Okay. So now we're going to look at a problem so we can start to see this in action. But basically all that this means, all that I've written here, this just means dy dx and y, and whatever's in front of y are on the same side, and dy dx is by itself, completely by itself. You see, it is by itself. Okay, and then there's some other function on the other side. That's all it means. It's not trying to be creepy, but you do need to know what's in front of y, and there does have to be a plus sign here. Okay, so we're going to look at an example, and you're going to understand it very, very well. Okay, so x dy over dx minus 2y equals x squared. So what's the first thing that you see that's an issue? Alright, well, I look at this and I see a couple things. I see a minus sign, and I see that x that's in front of the dy dx. There's not supposed to be anything in front of the dy dx, okay? So first step, we're going to divide out by x. That side by x, divide that side by x. Well, that's pretty simple. On this side, x squared divided by x, just x. On this side, we got those canceling out, so we have dy over dx minus 2 over x times y. Alright. Now, remember how I said the minus sign also concerned me, so let's go ahead and make that a plus and put the minus in there, just to make sure we don't screw anything up later. Alright, so now I want you to look back at this standard form that we had. Look, we got it basically in standard form. We have the dy over dx, we have the plus sign, we have the y over here on the same side, and so this is our p of x, right? That's the same thing as up there. That's our p of x. So now we're going to find the integrating factor. Now the integrating factor in any differential equation is just e to the integral of px times dx. Okay, so in this case we said p of x is -2 over x. Alright, so that just means, let's use our good integral rules. Let's pull out that negative sign, and let's pull out that 2. So then we just have 1 over x dx. And we all know the integral of 1 over x dx. That's easy, right? It's just -2 ln of x. Now let me tell you, very frequently in these problems with an integrating factor, you will get e to the ln of something, or some stuff in front of it, whatever. Okay, but remember, e to the ln just equals 1. Okay, so in this case, and you might want to review your exponent rules a little bit when you do these problems. But what's going to happen here, the e and the ln are basically going to cancel, and you're going to get x to the -2, because whatever's in front of the ln comes up here to an exponent. So you're going to get x to the -2, which is 1 over x squared, right? Alright, so now, let's get rid of some of the stuff we have here, and let's move forward with the problem. So, we got that our integrating factor is 1 over x squared. I'll rewrite that, don't worry. And then we want to keep some of the stuff we have over here. Oops, I didn't want to get rid of the y. I'll put it back right here. Okay, so this is what we have now in our IF equals 1 over x squared. So let's finish solving this problem. So after our first step was getting it into the form that you see above, our second step was finding the IF, the integrating factor, which is just e to the integral of p to the p of x dx. Okay, and then our third step is going to be multiplying both sides by the integrating factor. Alright, so that means we will have dy over dx plus -2 over xy equals x, 1 over x squared, 1 over x squared. That's what we're multiplying it by, because that is the good old integrating factor. And then we're going to take the integral. This is our fourth step. Take integral of both sides. And when we take the integral of both sides, there's a really important trick that you have to remember. This side is just going to be, you're just going to be normal here on this side. We look at that, we know that's ln x. Let's go ahead and put the plus c on that side. But this side, whenever you multiply the integrating factor by all this other stuff that you had, the entire left side, all that stuff, it's just going to equal y times the IF. So y times 1 over x squared, which is just y over x squared. And then you multiply each side by x squared. You're going to get x squared ln x plus c times x squared. There you go. That's the solution to the problem. And of course, if you had a point, you would plug it in and find a particular solution, but that is just a general solution. So these are the steps that you need to remember. You know, just getting into the right form, finding the integrating factor, multiplying both sides by the integrating factor, and then taking the integral of both sides. When you take the integral of both sides, do not take the time to work that all out. Just remember it's y times the integrating factor. It always is. Y times the integrating factor. Always is. And then from that, you just solve it like normal. And so that is how you use the integrating factor, and that's the integrating factor method of solving an inseparable differential equation. So I hope next time you have a differential equation that you can't separate very easily. Try to use the integrating factor. It'll really make things easier for you. You just got to memorize these little steps, memorize that standard form, and you'll be all set. Alright, thank you for watching.